You wake up from a dream so vivid it feels real. You were somewhere strange, talking to someone you haven't seen in years, maybe flying, maybe falling. For a few seconds, it's crystal clear. And then, it's gone. Not faded, not blurry, just erased. How can your brain create an entire world at night and then delete it before you even sit up in bed? If you enjoy learning how your body-mind world really works, subscribe now, because this channel breaks down complex things in simple ways. Because what's happening in those first few seconds after you wake up is one of the strangest things your brain does. And once you understand it, you'll never see sleep the same way again. Here's the big picture. Dreams mostly happen during a stage of sleep called REM sleep, rapid eye movement. Your eyes move quickly under your eyelids. Your brain lights up with activity. In some ways, it's as active as when you're awake. But here's the contradiction. During REM sleep, the part of your brain responsible for logic and structured thinking, the prefrontal cortex, is quieter. Meanwhile, emotional and visual areas are highly active. So your brain is generating powerful images and feelings without strong logical organization. It's like a movie studio running at full speed, but the editor is asleep. Now, most people think we forget dreams because they're not important, or because we just didn't try hard enough to remember. That's not quite true. Forgetting dreams isn't laziness, it's biology. And this is where it gets interesting. To understand why dreams vanish, you have to understand how memory works. For something to become a lasting memory, your brain has to do three things. It has to encode the information, it has to stabilize it, and it has to store it. During the day, this process depends heavily on a brain structure called the hippocampus. Think of the hippocampus as a temporary librarian. It takes new experiences and decides where to file them. But during REM sleep, the hippocampus behaves differently. Studies show that levels of a neurotransmitter called norepinephrine drop dramatically during REM, almost to zero. Norepinephrine is linked to alertness and memory formation. No norepinephrine, no proper encoding. It's like trying to save a document on your computer while the save function is temporarily disabled. You can write the file, you can edit it, you just can't store it properly. So your brain creates this intense dream experience, but it doesn't tag it as something that needs long-term storage. And when you wake up, the window closes fast. Within seconds, your waking brain floods back online. Logic returns, attention shifts, sensory input from the real world rushes in, and the fragile dream trace collapses. But that's only half the story. There's another reason dreams disappear so quickly. Your brain is constantly filtering information. Every second, it decides what matters and what doesn't. If it didn't, you'd be overwhelmed. Dreams often don't pass that filter. They're fragmented, illogical, emotionally intense, but narratively unstable. When you wake up, your brain almost treats them like background noise, unless something stands out. Emotion plays a huge role here. Research shows that emotionally intense dreams, especially frightening ones, are more likely to be remembered. That's why nightmares stick. Your brain flags them as important. Historically, some cultures believed dreams were messages from gods or omens about the future. In ancient Greece, people even slept in temples hoping to receive meaningful dreams. But from a neurological standpoint, most dreams are more like internal simulations. Your brain rehearsing possibilities, processing emotions, reorganizing memories. And simulations aren't always meant to be archived. Now here's where things take an unexpected turn. Some people don't forget their dreams. In fact, certain individuals can recall multiple dreams every single night in vivid detail. Brain scans reveal something surprising about them. They show higher activity in an area called the temporoparietal junction. This region is involved in attention and processing internal thoughts. In other words, these people may wake up with a brain that pays more attention to its own internal experiences. Their brains treat dreams as data worth keeping. Which raises a fascinating question. Are dreams forgotten because they're meaningless or because your waking brain decides they are? This matters more than it sounds. Dreams are closely tied to emotional regulation. During sleep, your brain replays fragments of experiences, especially emotionally charged ones, in a safer environment. Some scientists describe dreaming as overnight therapy. Imagine your mind taking stressful moments from the day, stripping away some of the sharp edges, and reprocessing them. If the emotional charge decreases, you feel better the next day. But if you constantly suppress or ignore emotional signals during waking life, your dreams can become more intense, sometimes more chaotic. And if REM sleep is disrupted by stress, alcohol, or sleep deprivation, the balance shifts. Alcohol, for example, suppresses REM sleep early in the night. Later, when the alcohol wears off, the brain rebounds with intense REM activity. That's why people often report strange, vivid dreams after drinking. It's the brain overcorrecting. But here's the deeper mechanism. During REM sleep, your brain is highly active in the visual cortex and the limbic system, which handles emotion. The amygdala, your emotional alarm center, is particularly active. Meanwhile, the dorsolateral prefrontal cortex, responsible for rational thinking and working memory, is dialed down. So you get strong emotions, strong imagery, weak logic, weak memory encoding. Imagine trying to write a story while your emotional system is shouting ideas, your imagination is painting wildly, and your memory librarian is half asleep. The result is powerful in the moment, but unstable. When you wake up, your brain state shifts rapidly. Neurochemicals change. Norepinephrine rises. Serotonin stabilizes. The rational mind boots up. It's like switching operating systems. And the dream belonged to the previous system. If you don't rehearse it immediately, by thinking about it, speaking it, or writing it down, it fades because the neural connections were never fully reinforced. Memory is like a path in grass. Walk it once, it's barely visible. Walk it repeatedly, it becomes a trail. Most dreams are walked only once, and then abandoned. But what happens when this system fails? In certain conditions, like PTSD, people don't forget their dreams easily. Nightmares can become persistent and intrusive. The emotional charge remains high. The brain repeatedly encodes the experience. In narcolepsy, where REM sleep intrudes into waking life, dreams can feel startlingly real and memorable. The boundaries blur. On the other hand, chronic sleep deprivation reduces REM stability. Emotional processing suffers. People become more reactive, less regulated. So forgetting dreams isn't necessarily a flaw. It may be protective. Imagine remembering every dream in full detail for your entire life. Thousands upon thousands of surreal narratives, conflicting identities, emotional storms. Your sense of reality could blur. Your brain may be discarding dreams the same way it deletes temporary files, keeping what's useful, clearing what's not. But here's the mystery we still can't fully answer. Why do some dreams feel profoundly meaningful? So real that they shape decisions, inspire art, change relationships. Many creative breakthroughs have emerged from dreams. The structure of the benzene molecule reportedly came to chemist Auguste Kekulé in a dream of a snake biting its own tail. Paul McCartney famously heard the melody of Yesterday in his sleep. So if dreams are mostly unstable simulations, why do some carry insights strong enough to survive the forgetting process? Maybe forgetting is the default, and remembering is the exception that signals significance. Or maybe the act of remembering is what gives a dream its power. When you wake up tomorrow and that strange dream slips away again, consider this. It didn't disappear because it was worthless. It vanished because your brain made a decision in milliseconds about what belongs in your story of reality. Your mind creates entire universes each night. characters, conflicts, emotions, landscapes. Then, with the flip of a neurochemical switch, it sweeps most of them into silence. And that leaves us with one final question. If your brain can build worlds so vivid you believe them and erase them just as easily, how certain are you that waking reality feels solid simply because your brain has decided to remember it?